We're here with Dr. Sanjay.Limaye from UW-Madison, and he is a distinguished scientist who has worked for decades on different missions and projects related to Venus. And he has come here today to tell us some more about his work and about Venus. And so we're going to welcome you. Thank you for coming, Dr. Limaye.
Thank you, Vicki. It's a pleasure to be here in Eau Claire on this day. I think I've been in Wisconsin for more than 4 decades, completing my 5th decade, and I've never seen snow in Wisconsin this early, at least not in Madison, maybe Eau Claire, possibly like October. That's crazy.
And an actual substantial snow too. It's not. It's going to be an inch. Yeah.
Yeah. And I mean, people wonder about climate change and what's causing it, and whether it's natural or human caused. I think certainly this is a difference in weather, certainly, but to be sure, I think definitely climate change. And I think there's a connection to Venus because for many years, people working on Venus have been wondering, how do we actually sell the idea of going to Venus? What do we learn from going to Venus? And one of the obvious thoughts that comes to most people's mind is that Venus has the most extensive greenhouse effect we know. In fact, many years ago, Alan Crawford, when he was building infrared detectors, and he wanted to test them, so the best infrared source in the thermal near infrared between 1 and 3 microns was Venus. So he aimed the camera at Venus and made a fantastic discovery because he was trying to measure the temperature of the night side of Venus.
Oh,
he
okay.
was detecting emission from Venus.
Okay.
Because the surface of Venus is so hot that we can actually see the glow. And to his surprise, instead of looking like a bright spot, he saw structure on the Venus night side, and that was an amazing, astounding discovery that we are still following up. But my point is that Venus is very hot, and the question is, if Earth and Venus are similar, they're roughly the same size, not too far in terms of the distance, in terms of the planets. Pluto is like 40 times away compared to Earth, but Venus and Earth are pretty close together, and their mass is similar, size is similar. But Venus doesn't have seasons, and Earth has seasons because it is tilted at 23.5 degrees. But Venus actually absorbs less sunlight from the sun than the Earth does.
Even though it is closer to the sun.
It is closer.
Okay.
And people usually get this question wrong. Why is it? Why do we have seasons? When you can see the Harvard series about somebody interviewed Harvard graduates and asked about seasons and why is it cold in December and not in June, and people get that answer wrong.
They think we're further away from the sun instead of tilted away from it.
Yeah,
Yes. Yes.
So Venus doesn't have that problem. It is almost perpendicular, so the poles never receive any sunlight, and yet they are just as warm as the equator. And the surface of Venus is about 900 degrees Fahrenheit.
Oh my God. Okay.
Almost 450 degrees centigrade. How did it get so hot? It's because it has too much carbon dioxide in its atmosphere. Just like Mars. But unlike Mars, the surface pressure on Venus is the same pressure you would get going 1 kilometer deep into the ocean. That's 6/10 of a mile underneath the ocean.
And what is causing the pressure? What causes that pressure on Venus?
The atmosphere is so thick.
Okay.
And it's all from carbon dioxide.
Wow.
And if Earth and Venus formed roughly at the same time, from the same planetary nebula that created the sun and the planets, why did Venus diverge? And when did it do that? And what does it tell us about our Earth's future? That's the question. So that used to be the question that people tried for many decades to convince NASA that we should go back to Venus. What happened was, you have a picture of Venus painting or drawing, or not drawing, but a digitally altered picture, I think.
Hmm.
Of
From the
surface of
Magellan,
Venus
from the
Earth,
Magellan
from the
spacecraft.
Galileo.
Yes.
Well, that was launched by the space shuttle in 1992, I think.
Right.
And that's the first time we actually were able to see what the surface might look like globally, because many years earlier, the Soviet Union back then had sent probes and taken pictures of the surface from entry probes,
Okay.
9 and 10, way before Viking landed on the surface of Mars and sent the first color pictures of the surface. We had pictures of Venus before we got to Mars.
Okay.
But the Soviet probes also told us that the surface was very hot, and once people realized that it was too hot, suddenly people lost interest in Venus. The prestigious American Association for the Advancement of Science, which publishes this journal, they excluded Venus from a press conference many years ago, that to the conference to which I was invited, but they didn't include Venus in their press briefing.
Oh.
They said, oh, we already know about Venus.
Oh boy.
It's too hot. I said, what? There are more questions about Venus than any other planet that I know of, and there are more mysteries.
Mm-hmm.
And right now, the current bandwagon is search for life. You know, we are going to
Yes.
send astronauts to the moon, to Mars.
Yes.
First to the moon, then to Mars.
And the excitement around the Dawn mission with Ceres and the
Because
finding
they
of
also
water.
discovered some, there's this bright spot on Dawn, and we don't know what it is. Is it water ice? Are there organics?
Mhm.
The central question is, are we alone?
Right.
Where did life, or when and where did life begin? Is there life elsewhere in the universe? And at this point, I'm ready to argue that if you want to look for life, the planet to go to first is Venus.
And is that to look back though at our possible future and look to see what happened to life on Venus? Or are you saying that there could be life on Venus?
There could be life on Venus.
At those temperatures?
I'm not talking about human beings or
Correct.
creatures,
Right.
but
Not life as we know it.
primitive life.
All right.
Because Venus also had liquid water on its surface sometime in its history. How far back, we don't know. But we know there was water. We can still see water leaving Venus. And Venus has many mysteries. And like I said, I think it's the most mysterious planet that is so close to us. We can go there in 4 months travel.
Mm-hmm.
And we have been there many times. But there are still more questions.
And I was reading that when we send a satellite there, we can get the images in the same day.
Well, yeah, I mean, the light time is only 8 minutes, I mean, it varies depending on whether Venus is related to Earth, it's on the other side of the sun. Then for about a month, we can't get any data because the sun interferes.
Right.
But except for that, we get quickly.
Okay.
So, if Venus had liquid water, what happened to it?
Mm-hmm.
And if it had liquid water, I mean, if you follow the same argument that if Mars had water, follow the water, that was the mantra for Mars exploration. That wherever there is liquid water,
There might be life.
there might be life.
That's
So
right.
if Venus had liquid water, and very few people will disagree with that. I mean, there is no liquid water on the surface today.
Right.
And
There could be some underneath though, they're speculating, or ice.
on Venus, if it's there, it's probably locked up as minerals, as hydrates,
Okay.
because the surface was redone in a sense sometime in the last few 100 million years ago by volcanoes. Venus has more volcanoes than any other object we know of. It has at least 1,000 volcanoes all over the planet.
Mm.
How many of them are active today? We don't know. Why don't we know? Because the complete planet is shrouded in a thick cloud cover that starts at about 30 miles above the surface
Oh wow.
and extends higher to almost 45 miles.
Oh my
so it's a
God.
thick cloud cover.
Okay.
And that's why we don't have as sharp images of the surface of Venus as we have of Mars, because from orbit you cannot see the surface except through radar.
And from the time that we started to research Venus, have we noticed that this carbon dioxide atmosphere has increased in size, or has it changed in chemical composition, or has it remained pretty stable the way we first found it when we first went there?
I'm glad you asked that question, because the discovery that Venus has an atmosphere is the first discovery in planetary science.
Oh,
And that was through a fortuitous event that was predicted by Sir Edmund Halley, that Venus will cross the path, or rather will pass in front of the disk of the Sun. It's called a transit. And just 6 years ago, we observed the last such occurrence in our lifetime, because these transits occur roughly a century apart. The next one will be in the 22nd century, something like 2112 or 15, something like that.
okay.
But people were trying very hard to observe this transit, and back then we didn't know how fast light travels, or what is the scale of the solar system. We knew the Kepler's laws,
Right.
so we could predict the orbital movements of the planets, but how far were they? There was no easy way to tell, and I think that's why people were trying to get some ideas. And so here's a picture of the first drawing or painting. It's hanging in the Manchester City Hall, I think.
Oh, neat. Okay.
Famous picture, and this is Crabtree watching the transit of Venus with his family. This is, I think, 1639.
Okay.
That was the first transit of Venus that was observed by humans, and it was observed by only 4 persons.
Wow.
The last transit of Venus was watched by hundreds of millions, if not a billion people.
Yes. Yes. It was really neat to watch.
Right.
And it was all in real time almost when we were
Exactly.
watching it on our computers.
And so you can
Yeah,
see
it was pretty cool.
the transit scene from a spacecraft. This black disk that you see is the planet Venus. And for the first time in 2012, and if you actually see this picture, I can send this to you. You see a little bright ring. That's the sunlight passing through the atmosphere of Venus. And
Okay.
people have now modeled the brightness of that bright ring, and now we can infer temperature. So that's the first actual discovery during a transit since the first one that Venus has an atmosphere. And actually that was how the discovery was made by Mikhail Lomonosov in St. Petersburg. He was observing the transit in 1761, and he saw that Venus didn't quite look sharp. It had a little fuzzy glow around it, and so he made that discovery that Venus had an atmosphere. Until that time we didn't know, and that was in 1761. So that was the first discovery. So, and then when the telescopes got improved, people tried to infer the composition, and carbon dioxide was suspected. But regarding the question as to is the composition or is the amount of carbon dioxide changing or not, we don't know. We don't actually, just in the last few years, we have a doubt as to what is the actual bulk composition of Venus. Take Earth, for example. Roughly, the primary constituents of Earth's atmosphere are nitrogen and oxygen. Well, oxygen was not the original constituent.
That's right.
Later on, once life started.
Yes. It was actually a byproduct.
It was a byproduct of life.
Yes.
And so carbon dioxide was the primary constituent when Earth first formed, just like Mars and Venus. But on Earth and Mars, the proportion of nitrogen and oxygen today, sorry, not Mars, because Mars doesn't have oxygen, it has ozone, but it has very little light, but there's something else going on there that we can talk about later. But nitrogen and oxygen, we believe it is well mixed. If you look up the US standard atmosphere, it will tell you that it is assumed that up to 87 kilometers, the proportion of nitrogen to oxygen is the same. Now oxygen is slowly decreasing, but it is
I've been reading
decreasing
that.
so slowly that we ignore it for the most part.
And we might be able to evolve into it.
Not quite, no, not that far. I mean, it's not such a dire situation, but the reason for decrease of oxygen is something entirely different. But on Venus, the pressure is so high that both the primary constituents, nitrogen and carbon dioxide, are what is called a supercritical state. And
Could you say that again?
Supercritical.
Oh, supercritical, okay.
And it's a state where the properties of the fluid become very strange.
How
And
so?
they don't like to mix. The
Oh.
viscosity goes to zero. And it may cause separation of carbon dioxide and nitrogen
Oh, interesting.
below that layer. And that happens below about 4 kilometers altitude, or roughly slightly 2.5 miles above the surface, mean surface of Venus.
Mm-hmm.
Carbon dioxide goes supercritical because its pressure at that altitude is the same as the critical point pressure for carbon dioxide. Nitrogen becomes supercritical higher.
Okay.
And so that might cause the separation, and that may have some strange effects. Now, many of you may be drinking decaffeinated coffee. Very few people know how that coffee is decaffeinated. I mean, from what I hear, Nestle perfected the process of taking the caffeine out by using supercritical carbon dioxide.
Mm.
When you immerse the coffee beans in supercritical carbon dioxide, it acts like a solvent and it extracts the caffeine out. And then basically you just bring it out and there's nothing left to it. So carbon dioxide has been used as a supercritical state, carbon dioxide as a solvent for a long time. But that's what we have on Venus. It's the only planet where we have such a state. What effect does it have on the minerals? Because it can have some effects on the minerals in the ground, and that people are looking into that for Earth. So, just different questions, basic things that you take for granted for Earth, and by extension to other planets, you find out they can't apply. So if you're going to go explore planets around other stars and try to predict their properties, and from what I hear, the properties are so bizarre that we are walking on thin ice if we can't explain Venus.
Yeah. Another reason that we should still be exploring it, so that we can fully understand something that's in our backyard.
Yeah, see, the people who work on the interaction of the sun with planets, the magnetosphere, ionosphere, etc. Their first question about Venus, when they find out that Venus has no magnetic field, is that, why does it still have an atmosphere? Because if you don't have an atmosphere for decades, the belief was that the solar wind would simply blow off the atmosphere, like what happened at Mercury, if Mercury had an atmosphere, and what happens to many of these asteroids. They probably may have had a primitive atmosphere at some point, but because if they don't have magnetic field, they cannot hang on, they cannot bend the charged particles around them.
Mm-hmm.
And they pinch on the atmosphere directly, and their speed is so high that they just carry all the atmosphere away.
Mm-hmm.
It's happening at Venus. That's how we have discovered that hydroxyl radicals are escaping Venus, even today. So
Okay.
Venus is still losing water.
Okay, but
Is
we
it being
don't.
resupplied?
But we don't see the water, or we don't
have
feel
any
that there's
water.
any water on the surface or under the surface.
Well, under the surface we don't know.
Okay.
Because we still don't know, like I said, water could come out through eruptions. Volcanic eruptions.
And with all the
usually have
volcanoes,
steam and
yeah.
Methane, sulfur dioxide. We see lots of sulfur dioxide and Venus is over the clouds.
Okay.
And one of the mysteries is that, well, first of all, we have cloud on Venus. And we also have, we see clouds on Earth. I mean, here are just some, let me show you a different picture. Here's what Earth looks like at different wavelengths, from visible to thermal infrared. These weather satellite Himalaya, but we get these from the GOES 16, the current US weather, the latest weather satellite around the Earth. And you can see these pictures on the web every day, every hour, every half an hour, something. But the point I wanted to make was that today, of course, it's cloudy where we are. But if you go someplace else, it won't be cloudy. How do we know? Because we look up, we see clear sky. On Venus, you don't see clear sky.
What would you see?
Clouds.
All the
Just
time?
like here, all the time.
Okay.
Everywhere you go, pole, equator, doesn't matter. Venus clouds, however, are very different. Oops, I think I went the wrong way.
Oh,
And these are pictures of Venus at different wavelengths. And in every wavelength that we have seen, there's a slight different appearance. On Earth, we can make out these cloud patterns, their structures, their morphology, in all the wavelengths, but not on Venus. So there's something different about the Venus clouds. And one clue is that if we look at Earth, this picture here, this is the only wavelength. This is water vapor, about 6.3 microns.
mm-hmm.
Here, the water vapor blocks the radiation leaving Earth's surface. And so what we are seeing are the variations of the amount of water vapor in the atmosphere. You don't see anything else. And so the dark patterns are where there is no, and I can blow it up, but you can see it, is where it is very dry. So we are seeing different abundances of water vapor. What are we seeing on Venus? These patterns caused by something absorbing in the atmosphere? If so, the question is, why is it well mixed? Remember, I told you earlier, Venus has no seasons.
Right.
It has very little topography. The difference between the highest point and the lowest point on Venus at the surface is less than 2 or 3 miles.
Okay.
Venus is as smooth a planet as you can get, except maybe Pluto. But that's an icy ball anyway. On Earth, the difference between Mount Everest and the deep trenches in the ocean is at least 10 miles or so, I think.
Mm-hmm.
So if Venus is so smooth, it's perpetually cloudy, no seasons, it has no vegetation on the surface, which means no differences, no snow cover, no oceans, no crops, no forests. So the surface reflectance, reflectivity is the same all over.
Okay. That would cause this uniformity?
That would cause this change.
Okay.
There's no hydrologic cycle on Venus.
Are there winds?
There are plenty of winds. In fact, that's one of the mysteries about Venus. On Earth, if you float in a balloon up at about 500 millibars, 300 millibars, roughly 3 or 4 miles up in the air, it'll take you about a month to go around the Earth at the equator. And people have done it. People have flown in balloons, hot air or helium filled balloons. On Venus, instead of a month, you can go around in 4 days.
Oh.
So that's called the super rotation.
So it's
Winds are
spinning
moving
really. It's
faster.
spinning really fast.
And actually, no. Venus is one of the slowest planets. It spins so slowly that it takes longer to spin about itself than to go around the sun.
Oh my gosh. So the super rotation is just in the winds that are surrounding it.
Yes, but there's one other quirk, that its spin axis is pointed upside down compared to most planets. So instead of spinning from west to east,
Okay.
it is going backwards, east to west.
Even though it's rotating around the sun
The same way as
the
the
same
other
way as
planets.
Earth. Oh, interesting.
How did that come out?
That's interesting, yeah.
That's the biggest mystery there is. All the planets go the same way, and we know that a few planets, Earth and Mars, for example, they got tipped because they got hit by objects, and they got tipped. Uranus, same thing happened, and so it's spinning basically in its orbital plane.
Mm-hmm.
Pluto is also weird in terms of its spin axis, but Jupiter is almost upright like Venus, with small tilt. Saturn is 26 and a half degrees, slightly more than Mars, and 27 something.
But we also wobble in that
But that's,
degrees.
yeah, but not Venus.
Stays upright the entire time.
So the question is, whatever that material is, why do we see such patterns on Venus at all? Why isn't it well mixed? That's the first mystery.
Mm-hmm.
And people for the last 50 years, now these patches, especially in the ultraviolet, and over here, this is the shortest wavelength, this is 283 nanometers, this is where the sulfur dioxide absorbs, this is 365,
Okay.
slightly shorter than the blue, the violet, and this is 0.9 microns, and this is 2.02 microns.
Hmm.
And this is interesting because at this wavelength carbon dioxide absorbs, so that's why the poles appear dark, and that tells us that the clouds are lower and over the poles which are at the bottom and the top of the picture.
Mm-hmm.
And that square hole is just an artifact. But these pictures in blue ultraviolet light, they were taken by an American astronomer from Milewski's observatory in 1920s. And
Oh.
we saw those patterns. And those patterns were used by the French observers, amateur observers. One of them was a lawyer, and he was alive until a couple of decades ago, Monsieur Charles Boyer. They followed these clouds for several days, and they came up with the result that the Venus clouds move every 4 days. So that's when the superrotation was discovered. The paper was published in Eau Claire in the late 1960s. And since then, we have learned more about the superrotation. I actually did my PhD thesis on it with the Magnet 10 data, which went to Mercury space, to planet Mercury, after flying past Venus.
Okay.
So that was in 1974, and then we were just mystified by Venus since then.
And the report that was published in the 60s that the rotation is every 4 days, did that hold up, did you find?
Yes, absolutely. And I discovered that the wind speed increases at about 45 degrees latitude. So as the forward you go, the rotation rate of winds may decrease to about 2.5 days.
Okay.
That was the discovery of the jet, and then came many other missions. But we still don't know. I mean, we found that out by following these clouds.
Right.
But we don't know what those. I mean, on Earth, the amount of heat we get from the interior is extremely small compared to what we receive from the sun.
Interesting.
And there was something else I was going to mention here that I forgot. Okay. So yes, Earth's albedo is about 30%. So Earth absorbs about 70% of the sunlight it gets from the sun. But most of that is at the surface. And so that's why it makes a big difference as to what the surface conditions are on Earth. Do we have snow cover? Do we have bare ground? Do we have crops? Do we have agricultural fields? Do we have trees? And that's what makes a big difference in how much energy is absorbed at the surface, and then the transformation of energy between the atmosphere and the soil through various effects is different. But on Venus, most of it is in the clouds.
Interesting.
And that's where the winds are fastest. And now we are suggesting that because we can't find any other plausible substance that can explain these contrasts, Going back to the idea that Venus had liquid water, why couldn't have life evolved on Venus? And if you had bacteria that evolved on the surface when there was liquid on the surface, that when the planet was warming up, those bacteria could have migrated to the clouds, just on winds.
Yes.
And that could explain some of the features that we see in the contrast, that they are colonies of microorganisms.
Moving
Just like you
through
see
the atmosphere.
algae on lakes or blooms in the ocean.
Fascinating. So you think the actual life forms could be
Life
living
forms could
in
be
that
extant
atmosphere
today.
circulating around Venus?
Right.
Interesting.
So we
Wow.
published that paper in astrobiology. It came out just in the print form in September.
Oh, yes, please send me a link to that. I'd love to read that.
Just Google Venus clouds life and you'll find it.
Okay. Oh,
It's the most publicized story from the UW campus all over the world. I've been on radio in Perth, Australia, in Radio Sputnik, in England.
it's quite a find.
Well,
Yes.
it's not a find. We're just asking the question. Is it likely? Is it possible? Because the hardest thing to do was convince people, Venus is so hard. Life? Are you crazy? Well, maybe not. Until you can explain to me what causes those contrasts and what are changing them and why they are changing,
Exactly.
I have this question.
Yeah.
I'm not claiming there is life on Venus.
But it is a possibility because of the factors that are there. Yes.
Because that's the only explanation that makes sense to me. The way they change quickly and how they are persistent. And so we made a case. Now that possibility of life on Venus in the clouds isn't new. Carl Sagan and Morawitz, actually, Morawitz and Sagan proposed it more than 50 years ago in 1967 in a paper published in Nature.
Okay.
But then immediately after that we discovered the Venus surface was quite hot and people lost interest. But then we discovered Venus had water in the 70s. And sometime later, Charles Coquelle, he was a postdoc at NASA Ames, he published a paper about whether life could exist in the clouds of Venus, and he said yes, all the conditions are there, there's liquid water, there's nutrients, there's energy. But then the idea didn't catch on, and basically it was languishing for more than a decade, and then some other people, David Greenspoon, who's a younger colleague of mine,
Okay.
he published a book, Venus Revealed. And in that book he has a chapter about the possibility of life, and he also talked about possibility. But that was way back in 2004, 2006, something like that. And all these years we were trying to explain what could create this contrast, and we couldn't come up with any explanation. And 2 years ago I was asked to join an astrobiology field trip in India. And a young student who had been on these Mars expeditions, space football.
Right.
That Chris McKay, a colleague at NASA Ames, had started. And he took teachers on those trips to try to educate them or try to expose them to the possibility of life on Mars, and so they would find these analog locations on Earth, and then they would talk to them about the conditions on Earth and Mars, etc. And so there was an attempt to go to extreme environments in India, very high altitude, 18,000 feet. I'd never been to that part of India, close to the border with Tibet.
The Himalayas.
In the Himalayas. And I said, I'm not a biologist, I'm not a geologist. What do you want me there? I said, no, you're the only planet scientist I know. Okay, for me to be a vacation, so I paid for the ticket and went there for 2 weeks. But I looked into it because he did say that, okay, we're going to some thermal springs. And that idea was in my mind because what had happened was that a few years ago, I was doing a workshop for teachers in Europe, the European Space Agency's technical center. we have developed a cloud tracking activity where we use this, anybody can use the same data that I use to measure the movements of clouds on the web. And we have targeted this for schools. And we are using the images from Venus Express. So I wanted to communicate that to the teachers, and so they invited me to participate in the workshop. And as we gave them the introduction, the talk about Venus, led them through the activity. And during my talk, I said that they're following these clouds, there are these light and dark patches, but I don't know what they are. For all I know, they could be bacteria. At the end of the day, a teacher from Poland came up to me and said, "Professor," no, Professor, we call me Professor. For my PhD, I was measuring the UV spectrum of some bacteria. Wow, that was news to me. I'm not a biologist. I have zero background in biology. I never even actually thought about bacteria having absorption features.
Right.
So he sent me a copy of the paper by email, and I looked at the spectrum, and when I looked at the absorption features, why? My jaw dropped, because it was close to what people had been suggesting for Venus through a chemical iron chloride, FeCl3. It was so similar. Then I looked at the name, Thiobacillus ferrooxidans. This bacteria found in the copper mines and is completely immune to sulfuric acid.
Oh, wow.
Suddenly,
That's when it really clicked for you. Yeah.
it clicked. Okay, we have bacteria that are not just acid resistant, but actually use sulfuric acid. That are using that as an energy source, extracting sulfur. We know there is liquid water. Could they exist in the clouds? And by that time, I had learned enough about the evolution of life on Earth that it started in the hot springs. When you go to the bottom of the ocean, near the smokers, that's where you find life. These tubes. And now there's more and more evidence that chemistry may have indeed be a catalyst, if not a trigger, for the evolution formation of life on Earth. We still don't know how it started. For all I know, it could have been on comets or whatever. But there were thermal springs in the Ladakh area on this field trip, 5 or 6 sites. And it'll be interesting to see if they're acidic and if they have any bacteria. That was my only connection and reason why I went.
And did they?
We sampled many of the thermal springs, and unfortunately, they all turned out to be alkaline, not acidic.
Okay.
I was disappointed. Then the last day we were at a lake, and actually it is this lake, Sokar. This is a picture from a satellite, and this is a picture I took. And you can see these white spots, they're salt deposits. And we were just walking along towards the lake, along the shore, and wherever I stepped, it was like a marshy area. Wherever I stepped, the ground would sink a little bit. As soon as you looked at the foot, you could see the water seep up. And in minutes, there were salt deposits, white.
Whoa.
I said, wow, this is interesting.
Very.
I was just helping a colleague collect water samples. I actually waded into the water, came back, and when I came back, it was about 1 o'clock or so in the afternoon. Sunny day, not a cloud in the sky. 18,000 feet, the air pressure was half the surface value,
Yes.
less than 500 millibars. Difficult to breathe, but
Yes.
okay. And then a wind gust came, and to my utter shock, some of the salt dust got lifted up into the air, and that was the eureka moment for me.
Wow.
I had never believed. I thought that I've seen enough salt deposits, salt flies.
Right. Yeah, I've seen it too.
Salt is crystalline. Usually it forms crystals right away, I thought. I could never imagine that it was not like a tornado, it was just a wind gust, like a dust devil. That small, light wind could lift that salt dust and
Bring it up into
the air.
Wow.
Could it have happened on Venus? And of course there were biologists. So So talk to them. I was supposed to give a talk about Venus on that trip, unfortunately because of the timing, and it never happened. But afterwards I wrote down my thoughts and I circulated them. And a couple actually responded back. And we finally managed to publish a paper with some colleagues from NASA Ames and Cal Poly, and this teacher in Poland who gave me the original idea.
Mm-hmm.
And now it's catching on, so we are now trying to see whether we can use this as a topic of investigation. Just came back from Russia. We were discussing a joint mission with the Russian Space Agency between NASA and Russia. And one of the ideas is to either fly, an aerial platform in the clouds, collect samples, and see if we can detect any biosignatures. So, in my mind, because it is so easy to fly and get to Venus, 4 months instead of more than almost a year or 18 months to get to Mars.
Mm-hmm.
You don't have to worry about site selection,
Right, yeah,
where to land. Because if you land in the wrong place, you may not find any life.
right.
Or if you're on Mars or Europa, then you have to dig. Because yes, Mars may have liquid water at high latitudes somewhere, but it's about a mile deep. We're deep there to find instant life.
Yes.
We don't have an issue with Venus. Just go anywhere, fly through the clouds, as low as you can get, towards 48 kilometers or about 30 miles. And if there are any bacteria, you'll find them. What kind of instrument do we need? That's what we are discussing right now, and I hope it will become a topic. We gave presented a paper at a symposium last week in Moscow, the 9th Solar System Symposium. I was unable to present it myself, but I asked one of my colleagues, my co-authors, to present it, and it was received well. I mean, this was the second time I presented at this conference. So I think the community, at least the Venus community, is becoming more open to the idea. And there was a workshop on searching for life through space and time that was organized by the National Academy of Sciences at UCL like 2 years ago. And I was the lone speaker, well, lone person at a poster. I didn't give a talk to present this idea about Venus. And I think people outside the Venus community are slowly recognizing, but they probably also see it as a threat to their own missions.
Right.
So ultimately, I don't know when we might have a mission that searches for life anywhere. Because the problem with Mars and all other objects is that there is a planetary protection protocol, both forward and backward.
Mm-hmm. Yeah.
And for Venus, luckily, there is no protocol.
Oh, that's interesting.
So that's the story. So that's why, in my mind, Venus is important.
Yes.
We have learned a lot from the planet through centuries. It's a morning star, evening star. You have paintings that you have drawn. You carry Venus and Mercury.
Mm-hmm.
They're both interior planets, just like Earth. Very different. But Earth and Venus, people talk about them as twins. And depending on the culture you are in, it could be a male or female character.
Mm-hmm.
In Native American stories, it's a prince.
Mm-hmm.
And around here, you hear lots of stories from Native Americans about Venus.
Mm-hmm.
In Hindu mythology, it's also a male. Interesting.
Okay.
But most of the cultures, they have it as a female.
Yes.
Birth of Venus, Botticelli's painting.
Mm-hmm.
I don't know. So Venus is mysterious. That goes with, if you consider Venus as a female character, perhaps. But we don't understand it.
Right.
From the basic questions, is the atmosphere well mixed? What are the clouds made of? What are the contrast features? Why are they well mixed? I mean, that to me is still the most puzzling question. Why do we see cloud morphology at all? Why isn't it just one big white surface with no detail?
Right.
What's the substance causing it? To me, that's the biggest mystery. And of course, my geologist colleagues will tell you about the surface. You know, the surface is complex. You don't know whether Venus has quakes or not, because the fractures in the terrain that you see in some of these synthetic aperture radar images is complex. You can't explain it easily. We know there is topography, there are volcanoes, craters, there are impact craters even, but the atmosphere is so thick that only the largest objects can reach the surface and impact. Otherwise they get knocked out in the atmosphere. But to me, it's the most mysterious planet there is, and so close. I wish we'd get there often and soon enough to sample the many different areas that we need to explore in terms of answering the question that we have. The trouble is that, you know, every mission has a limited budget.
Right.
You can only do so much.
Right.
Look at Dawn, for example.
Yes.
Yes, it did go to 2 different asteroids. It's a small spacecraft. But they had a simple task, just map the surface and see what it's like.
Right.
Well, on Venus, we don't know what the surface looks like at the same resolution that you have mapped on Mars.
Mm-hmm.
That's a mission in itself. We don't know what the clouds are like. That's another mission in itself. We don't know what the solar wind interaction is. Why is Venus still hanging under its atmosphere? So, exploring Venus, understanding Venus, it's got so many different questions, and it's a major undertaking. And I think it will happen only through different agencies collaborating or coordinating at least on the exploration. So I'm hopeful. I think we have signs that the Indian Space Agency may send a mission to Venus. The Europeans are considering a mission to Venus in the 2030s, and they are discussing a joint mission with Russia, and NASA may do something on its own. So we'll see.
Fantastic. Now, even though I know that your interest now is lying in the atmosphere and the bacteria that's around Venus, is also some of the research that you want to do in that atmosphere tied to, as you were talking about earlier, a possible future that we might see here on Earth?
Well, I think that question has been asked before in Jim Hansen and they were at a workshop on comparative climatology. And, I had helped to organize, and I was the chair of the Venus Exploration Analysis Group. We did it at Boulder, and I invited them both, and they actually had a debate because, you know, on Earth, people have talked about solar cycles and their connection to changes in the climate and rainfall patterns. Exactly what the mechanism is not clear as to how the sun influences the clouds.
Right.
We know in terms of the energy balance, but that's different from solar wind causing cloud nucleation or cosmic rays. I mean, that has also been talked about. And if you want to answer those kinds of questions, I propose the idea that, okay, Venus has a relatively simple, well, not a problem, but a case. It's the simplest atmosphere you can explore. No seasons, no oceans, no surface biology, albedo differences, very little topography, 100% cloud cover. You can't create a simpler atmosphere than that in our solar system.
Right.
And if you want to take our fundamental laws, physical laws and chemistry and whatever, and try to explain them, which is what people are trying to do with the exoplanets. Explain Venus first before you tell me why I should believe you something that you're telling me about exoplanets.
Right.
That's my position. So the answer to your question is that can Venus become like, can Earth become like Venus? We are on the same path if we continue to increase the amount of carbon dioxide. I think in our own lifetime, just in the last few decades, the amount of carbon dioxide has gone up noticeably, almost by between 5 or 10%, I think. It doesn't take a lot of carbon dioxide to have an impact. And it's a fallacy that people think, oh, when you say salt because the atmosphere is so thick, well, that's backwards thinking.
Right.
The atmosphere is so thick because it got so hot because there was little carbon dioxide to begin with. The
Yes.
surface pressure was not so high. And there's a lot of web pages that will tell you, oh, no, it's nonsense. But that's not the case. It takes only a little amount of carbon dioxide to block the sunlight. Not the sunlight,
The heat leaving the earth, yes.
on the planet to track it. It's like taking on a blanket. You know, on a cold night, even a newspaper will help you stay a little bit warm.
Yes.
Doesn't take much. And because we have so much water, and we still don't know where that water came from. Did it come from comets? We have no clue. But because we have so much water, that it will take a long time, billions of years before we lose that. And by that time, the sun will have expanded and covered up the earth anyway, so it won't make any difference.
Right.
But the temperature will continue to rise, and there is a certain maximum temperature for Earth as a whole, above which the life as we know it will be impossible to maintain. So, we'll see.
Oh,
Thank you.
thank you, Dr.Limaye. And we're here at Galaudet Gallery with the Dancing with the Dawn exhibit. It's about Venus, and told us about his interest in it and why it's still such a mysterious planet that should be explored. And missions should be sent to Venus. It's something that we should learn about.